today's topic of discussion is the acceleration principle. So basically we are going to talk about the simple acceleration principle and the flexible acceleration principle. Before starting or before going to the flexible acceleration principle, at first we are going to discuss about the simple acceleration principle or fixed acceleration principle. Now this simple acceleration principle is actually tries to capture the role of the investment or role of the induced investment in the determination of income. That means how the how the investment is actually increasing, and how the income is being determined by the increased investment. When there is an increase in the investment, how can we derive the determination of income, or how can we derive the income from that induced investment? That is actually being told by the simple acceleration principle. So it tries to capture the role of the induced investment in the determination of income. Now there are some assumptions regarding to the simple acceleration principle. That is that kt star is equal to v into yt. Now what is kt star? Kt star is basically the optimum capital stock. What is yt? Yt is the output, and v is basically a constant. So our optimum capital stock is basically a constant proportion of the total output, or yt. Similarly, ye is equal to yt. What is yt? Yt is basically the output of the current period. And what is ye? Ye is the expected output for the future period. So what the person is actually expecting to be the future period output, and the current period's output of the person is actually same. That means suppose the person is thinking of getting 30,000 rupees of output in the future period, and in the current period the person is actually getting the output of 30,000 rupees. So that is being meant by ye is equal to it. Similarly, it star is equal to it, that is the fourth assumption. It refers that the planned investment is equal to the actual investment. What is actually the planning about investment? Suppose I have planned, or any farm or any producer has planned to invest 30,000 rupee in the process of production, and he is actually investing 30,000 rupees in the production process. So that is basically the planned production equal to the actual planned investment equal to the actual investment. kt star is equal to kt. That means the capital is optimally adjusted in the capital capital is optimally adjusted in each period. In all of the period, the capital stocks are equal. And the sixth assumption, that is basically the last assumption, that tells that it star is equal to kt star minus kt minus 1. That means if we subtract the capital stock of the current period, that is kt, and if we subtract that current period capital stock from a year back, or from the capital stock of a year back, that is kt minus 1, then we are going to get the planned investment it star. So that is equal to v into it minus kt minus 1. Now suppose that we are at period t. So let me say at first that please remember this third assumption. This assumption is very important, because this assumption will help us to go to the flexible acceleration principle from the simple acceleration principle. Now at period t, our investment is basically the difference between the capital of the present period and capital of the previous period. So that is basically investment of it, that is equal to kt star minus kt minus 1. That means the difference of the present period capital and the previous period capital. Similarly, it minus 1 is equal to kt minus 1 minus kt minus 2. Now it is equal to kt star minus kt minus 1. Now as we know that it is equal to what is the value of kt star? We have derived this in the assumption that kt star is nothing but v into yt. So kt star is nothing but v into yt. So we can put the value of kt star in this equation, that is v into it minus kt minus 1. What will happen at period t minus 1? At period t minus 1, the investment will be of t minus 1 period, and it will be vy into t minus vy t minus 1 minus kt minus 2. Now if we subtract this equation of it, this equation, if we actually subtract if we subtract this equation, that is it is equal to kt star, sorry, this is not this equation. If we subtract this equation and this equation, then we are getting this, and if we take common of v from this function, then that is basically v into yt minus 1 minus kt minus 1 minus kt minus 2. I have written it here also that it minus 1 is equal to kt minus 1 minus kt minus 2. That means if we are going to talk about the investment of the t minus 1 period, then we are actually talking about the difference of the capital of the previous period and a year back of the previous period. So that is basically it minus 1. So we are just writing it minus 1 in the place of this, and that means we are getting that this it minus 1 and this it minus 1 will cut down, and we are all getting it is equal to v into it minus yt minus 1. That we are writing is as del yt, that is denoting the change in the yt. So investment is nothing but a function of difference between two periods output, that is yt minus 1. So this is basically the simple acceleration. So this is basically the simple acceleration principle without any lag, as we have denoted. There is no lag included in it. And now if we include the lag in the simple acceleration principle, then what will happen actually? Now if we include the lag, then kt star is not v into yt. If we include lag, then kt star is basically v into yt minus 1. That means our optimum capital stock will be equal to a proportion of the previous year's output. That means in the earlier section kt was basically v into it. What do you mean by v into it? V into it basically meant that our optimum capital stock, that is kt, is a proportion. V is basically a proportion, is a proportion of the current year's output. But now when we are taking lag, we are including 1 year lag, so we are actually taking kt star is equal to v into it minus 1. That means our optimum capital stock is a proportion of the previous year's output. So it is basically nothing but kt minus 1 now, but in this case kt is or kt star is basically v into it minus 1 minus kt minus 1. Similarly, if we subtract, if we get the it minus 1, then that will be v into it minus 2 minus kt minus 2. Subtract this equation and this equation, we are going to get this value. Similarly, it will be cut down, it minus 1 will be cut down, and we are getting it is equal to v into it minus 1 minus yt minus 2. That means here our current investment is basically a function of change in output, but in this case the outputs are not of the current period, but the outputs are basically the previous period's output and the year back of the previous period's output. So that is yt minus 1 period and yt minus 2 period. We are going to talk about these two periods. Now as we know that the time varies, so we are just taking that kt is equal to v into yt as we have written. So this is basically, you can also write that kt is equal to v into yt as we have written in the earlier portions also. But suppose you want to write that I have just written it in the form that k of t is equal to, so if you want to write this in this form, then that is also okay. I have written it as in the form that k of t is equal to v into I of t. Both are acceptable and both are not having any kind of issues or problem. You can do both. Now, so k of t is basically v into I of t. So t is denoting the time period here. So it is equal to basically it, that is the investment that will be obtained if we do the derivative of this kt with respect to time. So we have done the derivative of kt with respect to t, that is time, and similarly when we are doing the derivative, kt is nothing but v into it, so we have put the value of v into it in place of kt, and v is a constant, so it will come out of the derivative, and dyt by dt will be in the derivative portion. So if we do it graphically, try to if we represent it, then it will be like this. it Now this is basically this portion, or this x axis is denoting the time, and this y axis this axis is basically denoting it, that is investment of the teeth period, and from this point it is denoting yt, that is the output of teeth period. Now till t0, this time period, our dyt by dt, that is this portion, it is increasing, our investment is also increasing, it, that is also increasing. At t1 till t1 what is happening here actually, from this after t0, if we consider after t0, that sorry so after t0 what is happening, after t0 the dyt by dt is actually falling, or dyt by dt is actually falling, that is basically this portion is basically falling. So dyt by dt is falling, and our investment it, that is also falling. Similarly at t1 period, this dyt by dt is maximum, so obviously dyt by dt is 0 because of the maximum point, and it is basically becoming 0 at this point, you can easily see. And after t1 our dyt by dt is falling, and t1 is becoming negative. You can see that our investment, or it is becoming negative. After t1 it is becoming negative, and what dyt by dt also is falling. There are some shortcomings of this simple acceleration principles. What are the shortcomings? Decision lag is present, but adjustment lag such as financial lag, administrative lag, delivery lag, both are absent. KT, if we are actually neglecting the rate of interest in this fixed acceleration principle or simple acceleration principle. If v is a variable, we are considered that v as a constant. If v is a variable, then we are not going to get the results. If the kt is basically greater than the optimum capital stock, that is kt star, then this acceleration principle will not hold.